today's episode we'll be going over the angles formed by secants and tangents. Really what this is really more is just kind of focus on secants and tangents, what they do, how they interact, how they intersect each other, and what they create. So let's take a look at this stuff. This looks super weird. Fix this. That's better. All right. So a secant. What is a secant line? Again, you should have in your vocab. You should have gone over it before. But what a secant line is, it is a line, a ray, a segment, right? Basically, something that intersects the circle. So it could be like a line. It could be a ray that intersects a circle at, well, okay, if this is our secant line, zoop, right there, then it intersects the circle at, well, 2 points. It intersects a circle at 2 points. Okay. So in this case, this one, right? We've talked about this other one before. This one is our tangent line. Because again, this one over here just intersects a circle at 1 point. Right there, so that makes this the tangent line. Actually cuts through the circle, as you can see, where the tangent line, again, just kind of skims the top of the circle and just hits that 1 point. Alright, so that's our secant line. That's the difference. If there's a secant and tangent, right, that intersect at this 1 point, this point, that's super useful, right? They intersect at the point of tangency. What happens is, if a secant line and a tangent line intersect at the point of tangency, so again, this point that I highlighted right there, point of tangency, then the measure of each angle formed is half the intercepted arc. The measure of its intercepted arc. All right. So what's happening here is that if we have these two lines, right, we have our tangent line, and if we have our secant line. Okay. The arc we're talking about happens to be, all right, so we got this full arc that we're looking at, right? Not this little bit, it's the intercepted part, right? The intercepted part is this difference that's from all the way over here. So it's the inside part, right? So the inside. So again, there's our point of tangency. It's, as you can see, I've left out that because it's all this that's on the inside. So the way this works, if we're trying to figure out the measure of angle 1, so this will be our angle 1, the measure of angle 1 is equal to half the arc which is x divided by 2, right? So if this is our arc, right, we divide that by 2, we got our angle. So yeah. So the angle is equal to the arc divided by 2. Alright, it's the same idea. And we've already had something like that before, right? I think our inscribed angles, the arc itself is twice as big as the angle, right? So it goes either way too. So it's twice as big, it's also 2 times the angle. Anything you want to talk about it. Alright, there you go. The last little foldable happens to be when two secants cross. So these two lines are two secant lines because they cross and they hit at the same point. They create this arc. But let's talk about this first. Let's go through this. Alright, it says that if two secant lines intersect, if two secants, I'm going to say intersect, in the interior of a circle, right, so it's at this 1 point on the inside, then the measure of the angle formed is, another one that we've kind of talked about before, is half the measures of the arcs that intercept the angle and its vertical angle. half the sum of the measures of the arcs intercepted by the angle and its vertical angle. All right. So what this means, right? What's going on here is that you have this angle, right? This angle A, or this angle 1. Again, it's a vertical angle, so this one's going to be congruent, right? Those two are going to be congruent, so it doesn't matter which one. But the idea is, if you were to add these two, oops, wrong one. If you were to add the measure of A and the measure of B, right, divided by 2, you would get the measure of these angles inside. So kind of the same idea, kind of what we looked at before. The measure of angle 1 is equal to A plus B divided by 2. Right? So if you add these two together, divide it by 2, you'll get the measure of one of these angles. Either one, right? So it doesn't matter. Same thing here, right? If you can also do it up here too, if you turn this sideways, all that. That's how it works out. Okay. The last little bit actually kind of has a lot going on to it, so it's going to take a while. So you got to turn this sideways. The exterior, secant, and tangent. All right, so there's three things that happen here. And this is probably one of the more confusing things that we do in this unit. It's for sure in this section. All right, it's kind of long, so as you can see. So let's write this out. If a tangent, or a secant and a tangent, I guess we should be writing this in blue. If a secant and a tangent, or two secants, two tangents, so two tangents, or two secants. All right, so a secant and tangent, tangents, or two secants intersect on, this one's important, right? On the exterior of a circle. On the exterior circle, the measure of the angle formed, right, and again, kind of going back to the stuff that we've already talked about, half the positive difference of the measure of the intercepted arcs. Alright, so a lot of stuff going on here. We're going to be writing a few things that with this stuff. So the secant and tangent, and two tangents or two secants, right? If they intersect on the outside, then there's a few, kind of the same idea, but let's take a look at this. Alright. Okay. So bear with me. The measure of angle EVN, so this one right here, EVN, is equal to one half of, leave some space. Hopefully I can hopefully I can fit this in. These two arcs that it creates. So this is a tangent and this is our secant line, right? So we have our tangent line and our secant line. So let me write this out. This is our tangent. This is our secant. All right, and the two arcs they create, you can kind of see them. There's one on this side. There's this one right there. You get this part and this other arc way over here. Add them, or subtract these two because it's the difference of them, right? Positive difference. So that's important, right? Positive difference. This means subtraction. But again, this is positive, so you have to be very careful in how we do this. So the way this works is you kind of want to take the bigger minus the smaller one. So this way, so this is arc EN minus F, which is EA. So to figure out what this angle is, you have to subtract the bigger arc from the smaller arc, then divide it by 2. All right. It's going to be consistent for all of these as well, too, as we kind of go about this. All right. Same idea here. We have these two tangent lines. And so again, this is our tangent right here. This is also another tangent. But if angle that we have, which is ARN, so in this case, the measure of angle ARN is equal to, and again what we had before, you take 1/2 of these two arcs that we already see here. All right, we can do this one. We'll do the big one again first, because you always want to take the big one, subtract it, subtract the little one from it. So the big arc, my arcs look disgusting, and this one, that's because the paper looks weird. There you go. And you subtract these two. So this one is, in this case, this one is AKN. That full arc minus, and then our little arc, which is A to N. AEN. AEN. Alright. We'll do the last one down here. Alright, so this goes this goes there, this goes there, and then we'll have one more that goes up there. Alright, but then that last idea, same concept, right? We still have this angle we're looking for. This angle right there. So then we'll do it here. The measure of the angle, in this case this is ATH. ATH is equal to, and again same idea, 1/2 fit it into that of our two arcs. In this case we have a smaller arc right here, CY, CY, and AH. Minus AH. All right. So there we go, right? A little bit more confusing, a little bit harder, but the idea is, again, just really, if you can label things, label what you have correctly, plug them into the formula, we'll get to it, we'll solve for this stuff, and that's what we're looking at, right? These halves are going to be annoying, right? There's a hint that we're going to do. It might help to times 2, so multiply by 2, and we'll get to that though, right? So that's a little hint that we can do to actually solve for this, because these halves are going to be super annoying. Right? Sometimes it's going to work out really well, but sometimes we have to multiply by 2. We'll get there though. But yeah, there you go. Secants and tangents.